What are these cracks from?
The horizontal cracks, I'm not sure what causes those. I don't know. But they're very common in many columnar sections. You see these horizontal fractures that go through the rock. And I don't know if that's also a cooling pattern or maybe just a flexure pattern of the crust. I don't know. Yeah, Joey Martin's lab. Okay. Over here. The South Hill is over there. Latah Creek goes up that valley over there.
Is that Hangman Creek?
Hangman, Latah, yep. So we're looking pretty much due east down the valley. Okay, we were out near that little hill out there earlier and we looked at rocks and then we came swinging back through the valley. So, it's 12,000 years ago and you start hearing a noise off in the distance.
You see clouds.
Low rumbling noise. It gets a little louder and about 20 minutes later it's getting louder and within about a half an hour you see something off in the distance. Can't really tell what it is, but within about 45 minutes this all starts filling up with water. And it just fills up and fills up and fills up. Starts swirling and swirling and swirling and swirling, eating away at the bottom of the cliffs here. Boulders tumbling down, eroding and falling down, and probably want to get out of here.
There's nowhere to get.
Yeah. A lot of the water goes up Hangman. A lot of the water goes down the valley, and some of it spills over the top here into eastern Washington.
It came up over here. It would have come
Some
right
of
over
it
here.
breached this level, but a lot of it flowed south through the Hangman Latah Creek drainage. But a lot of it did come up over the top and spill over and then start pouring into eastern Washington. And a lot went north up the Spokane River Valley, as we'll see.
Why does the Pend Oreille River flow north?
Probably because of the fact that it was filled with an ice lobe, and that as it retreated, the crust was depressed, so the water went that way.
Okay.
And interestingly enough, it's been rebounding, but it's been able to cut through that rebound, creating kind of a canyon. And if you look down here in the foreground, and as we go around the corner, we're going to actually go by that other college. Doomsday Hill is right around the corner. It's all sand and gravel. And we'll see it.
Because it's a bitch. Probably not going to see much. It's not spring yet.
Right. Do they taste good when you eat them?
Yep. It tastes like chicken.
Looking out at the valley, and then when we drove down, we came down and have driven down into the bottom of the valley here. So the basalt used to be up above us. This all used to be filled in with basalt, and then as the Missoula floods came ripping through, they eroded out the basalt, widening the valley, and then depositing the gravels. So that hillside over there is underlain by gravels. And then the Spokane River, when it started flowing again, has now eroded down through the gravels. It'd be kind of neat to do a study where you try to calculate what the erosion rate through the gravels is, how fast it's downcutting through the gravels. I don't know if anybody's done that or not.
Hasn't that changed a lot since they've thrown in a couple of dams?
Well, yeah, but you could do it on a kind of geologic sense. How many, meters per 100 years or 1,000 years, The problem is, though, that since the Ice Age, the amount of water flowing in the river has decreased.
Yeah.
At the end of the Ice Age, there's probably a lot more water flowing through here. But you could still come up with an erosion rate in general. But this is the so-called bowl and pitcher. I don't know which is the bowl and which is the pitcher, but it's out there somewhere. Be up, and they've caved off as the floods came through. On the pillows is obsidian, so you have these pillows that has obsidian. I know.
least now we know where to come when there's
Yeah, exactly. I've never seen snow down here, and I've brought so many field trips.
Even on that day it snowed all day.
Well, we didn't have a day that day. So then the question is, well, why did we have pillow basalts? Now remember, this was 16 million years ago. This little creek was not here. This is a very recent young erosional feature, this canyon here. Springs?
Yeah.
These are big. These aren't like, there must have been a
Huge
body of
pillows,
water
huh?
or something. Okay? So then, if you walk up the creek, see that kind of brownish stuff over there? There's basalt that comes down like that. See that brownish stuff? That's what's called the Latah Formation. There's even some white, and it's layered clay and siltstones that has fossils in it.
We can get over there.
No, we can't.
Why?
Because it's too icy. And it gets steep right down there.
Go ahead.
There's fossils, and the fossils are deciduous plant fossils.
Oh, now I want to go over there.
Leaf fossils. Now, if you look at the vegetation here,
Is it really that bad?
what kind of vegetation is it? Okay, runs through here, but right now there's no creek, right?
Right.
Okay. And in fact, in all the years I've come here, there's been only twice where there's been water actually filling the creek bottom. That was the winter of '96 and '5. Very wet winters, very rainy.
Is there water in through here all summer long then?
Well, there is a creek and it flows underneath us. We're on sand
Right.
and it seeps underneath.
Oh, it seeps underneath the sand.
Right.
Okay.
So, you see the basalt there. Now, come on over here. There's a little bit of obsidian on the edge of this little poorly developed pillow here. It's not great obsidian, but it's, see this, the rind?
Oh, yeah.
It's poorly developed obsidian here. And this is not a great pillow. I'll show you a little better pillow. The really best pillows are at the other end of the canyon. There's just gorgeous pillows. But this pillow right here ain't bad.
Oh, yeah.
See this weathered obsidian.
Wow.
And it
Weathered
weathers
obsidian.
really fast.
Look at that.
Yeah. So this was a big mass of pillowy basalt here. Okay?
So obsidian
That
weathers,
really
huh?
looks pillowy.
Yeah. Obsidian weathers pretty quickly, actually. Yummy. This is really gooey stuff.
It's all frosted.
Here's a little branch twig fragment right there. There you go. Now, this stuff is really muddy and slimy over here. What's that?
It filled it up.
Probably.
Evaporated.
Yeah, probably. It probably wasn't a very deep lake, but the pillows and the lava flows filled in the lake, sitting on top of it. In some places, they find the lake sediments were still real wet and mushy, and the basalts would flow in and they'd kind of sink in and form all these weird patterns. So it's kind of neat that these sedimentary rocks tell us a lot more about what this area used to be like some 16 to 18 million years ago. It tells us what kind of plants were here, what kind of climate, and what kind of geologic environment.
So there was a lot more sea level